Hi, welcome to the next edition of GridForward Forum. I am Bryce Yonker with GridForward. Today we have with us Sean Kelly and Xing Wang. Gentlemen, thanks for being on.
Thanks for having us.
Thank you very much.
All right, like always, maybe I'll let you each introduce yourself. Sean, we'll have you go first. What keeps you busy? What are you doing? What are you working on these days?
Yeah, I'm Sean Kelly, co-founder and CEO of Amperon, based in Houston, Texas. Amperon is forecasting for the energy transition. And so the company is 7 years old, and we focus on all types of forecasting in the electricity space. And that includes demand forecasting, where we started, and also renewable generation, wind and solar, as well as price forecasting. We are active in North America, Australia, and Europe. It's definitely keeps me busy.
Always hard to pick favorites, but one of our favorite companies really showing what AI can do on the grid. So thanks for being on, Sean. And then we have Xing Wang. Xing, if you can do the same thing, give us maybe a brief history of you and what are you working on these days?
Yeah, thanks, Bryce, and thanks for having me. A pleasure to be here. So I came from the energy industry. I'm based in Seattle. Worked at GE and Alstom before for the control room solutions and market solutions, and then worked at the Centrica business solution, providing the customer clean energy solutions for millions of customers. So I have been with AWS for 3 years. My current role is to lead grid modernization business development globally. What that means is that we work very closely with power utilities, grid operators, and solution providers to accelerate the industry's IT and OT transformation. And we help utilities and grid operators to kind of deal with the challenges that come from the significant load growth or extreme weather conditions and renewable integrations.
Thanks, Xing. Truly a grid expert and somebody we've known for more than a decade before this AI stuff was even really a twinkle in the eye of anybody. All right, Xing, I'll send the first one to you. What's a top priority at Amazon, in and around energy and grid areas? How are you guys thinking about this space?
As you probably know, Amazon is the world's largest renewable off-taker enterprise-wise, from globally. So we have over 400 renewable projects in the world. So the goal is to provide 100% renewable energy to power our business by 2025, although we actually achieved that goal by 2023. But
congratulations.
Thank you. And the priority really is to continue doing that to power the significant anticipated AI growth, which is going to be a challenge, a nice challenge. And in terms of grid, really what we want to do is to bring additional capacities, right? Not just looking at leveraging existing capacity, bring additional new capacities of renewable energy to the grid, and it's at the same time making the grid more flexible. And also accelerate that interconnection and permitting processes.
Great. So Sean, on your end, what sort of priorities are you seeing in the grid? Maybe some that Xing did mention and others that are out there.
Yeah, data centers are definitely top of mind. Everything's getting harder, right? When we started the company back in 2018, you looked at meter data was like once a month. You still had kind of the dog chasing the meter maid, and with smart meter data has gotten significantly better. You look at solar. I live in Texas, as I mentioned, and 90% of the solar has been built in the last 4 years, like on the utility scale side. That's wild. That changes. If it's cloudy, you don't get what you expect. The wind kind of does whatever it wants. When I started my career at Tenaska back in 2005, there was 2,500 megawatts of wind on the grid in Texas, and now there's 40,000. So, you're seeing all these things that are intermittent, and so forecasting is becoming so much more important. And also these large loads. Everyone thought that demand was going to stay flat because of energy efficiencies, which is what the main focus was back in the early 2000s, and now the load growth numbers are going through the roof, which I know we'll touch on more later.
Yeah. Maybe we won't debate it too heavily now, but how much is load growth going? And I don't need a particular number or percentage, but I know it's difficult for local jurisdictions to get to pinpoint an accurate estimate on this. Sean, do you just want to keep going and then maybe Xing adds a little bit?
Yeah, I mean the big issue here is there's a lot of like double and more accounting. One private equity will say this is my project, and somebody else will respectfully disagree, and they'll both put in for the same project. The large hyperscalers may say they want to put something in south zone of Texas or in west zone, or they may decide between like Virginia or like Montana, and they're not gonna build duplicates. And so I think that the double counting in the queue is going to be very hard. And utilities are they're in trouble from the standpoint of they thought that demand growth was going to be flat. We've retired a whole lot of thermal generation, and now growth on the load side is rapidly increasing. So it's going to be a lot. It's going to be significantly less than the high numbers that are coming out right now.
And Xing, maybe not exactly where you're growing, but just to give some numbers on how much you guys are growing. What's the scale?
The scale is absolutely very significant. I mean, I can't see how much in overall, but just the fact that our data center engineering team are looking at design gigawatt level data centers to power the AI growth. That just shows the load is going to be from data center side is going to be very, very significant for a local utility, for a grid operator to even manage and plan.
Yeah.
And certainly load integration is actually easier than the generation integration, because that represents economic growth, and the states and local government really like that they want to make it easier. But that does require to bring the power to that significant load, and that means the grid has to be really enhanced, and we need more capacity basically.
I can put a number out there. I'll leave the company anonymous. But I was having lunch yesterday with a major, probably the major data center developer, and I asked them about how many projects they had in motion. He said 50. I said 50. Yes. And their preference is to not build any of them less than a gigawatt now. Now, they won't be able to do all of them at that scale, but that's what we're talking about there. Mm-hmm. All right, let's talk a little bit about dynamics in the market. The new administration has not minced words as far as its interest to prioritize expansion of generation, increase domestic supply chain, and really has positioned AI kind of in the core of that from a competitive advantage standpoint. How do these elements kind of come together, and what do they mean on the grid? Maybe Xing, you can start.
Yeah, I think ultimately we need to build more transmission. I think everyone agree with that. We need a stronger grid, but that takes time, right? And in the near term, I think we want to use technology, including AI, to make grid more flexible. We can predict better, right? We can plan better, and we can interconnect those new generation capacity better, no matter whether they are renewables, batteries, or maybe natural gas even, or nuclear, right? So those things I think we can do, we can impact. So I think from AWS perspective, certainly we recognize that we one of the source of the load growth, but we also want to help the utility industry to move faster, right? To be more resilient, more reliable.
Anything you want to add on that, Sean?
Yeah, I definitely agree on having more transmission built, but it's hard, right? No one wants it in their backyard. It's really expensive. It takes a long time. The permitting process is pretty wild. And so I think that's where one of the things I really appreciate is the repowering of nuclear assets. And so really want those to get passed. I mean, we saw that with 3 Mile Island, with Palisades. There's more out there that can be done. So I really believe that nuclear, the answer that we've had since right after World War II, has been sitting here the whole time for net zero, but it's also reliable. And so I think that's what I really want to see. And then the other thing is flexible load resources. We need people to behave when we need them to behave. And that's where are you moving your computer around, or are you actually running your processes at times that are helpful? I mean, I really think we're going to see on the compute side a demand response or a virtual power plant type of being able to have that flexibility. So those are the things we can solve for I guess in the shorter term, its transmission is definitely one of the answers, but just takes a long time. As same with nuclear.
Yeah, I mean, to get at it, we got to build, no doubt about it. I got to put a shout out for GITS, right? Grid enhancing technology capabilities have really accelerated recently, and I think they can make a meaningful impact. And it's not like they're a no build solution, but all right, you guys both gave me some leads as to the next area I want to take our conversation, which is how are we going to use AI? Where's AI going to show up to help operators run our grid systems better? So I'll start this one with you, Sean. There's a lot of talk about what AI can do, but what are you seeing in the real world in the near term, as in the now, that's going to show up and really have a significant impact?
So the thing that's causing demand is also the thing that's going to save us. And that's where AI really comes in. Amperon has a late mover advantage. Many of our competitors were started in like the 90s or early 2000s. One of our biggest competitors is still good old Microsoft Excel. But at the end of the day, we started like cloud native, running multiple models. One forecast is never going to be the answer. And so we're always ensembling multiple forecasts behind the scenes. We're also looking at weather on a very granular weather. The weather improvement that we've seen over the last just 2 years has been like mind blowing. And weather's getting harder, so we've got to continue these improvements. So that's where AI comes in. We pick 40,000 different weather points. Back original forecasting 1.0 just chose the nearest airport because that's where you could get good weather. We look at everything from a grid. We went and took population density weighted data. And so as I sit in the middle of Houston, I'm 1 kilometer away from a weather point that we're looking at. If you're in the middle of the country, in the middle of nowhere, you're going to be 10, maybe even 20 kilometers away from a weather station. We're not going and doing that by hand. And we're also not going in and saying 25% of this model, 35% of this model. It's all automatically weighted. So the thing that's going to save us is also the thing causing the demand issue.
Cool. So forecasting, we might talk a little bit more about that. Xing, what else are you guys seeing show up now and be a real solution to help to have AI, run our grids better?
Yeah, I think definitely agree with Sean. Forecasting is extremely important. And by the way, Sean, I don't know whether you are aware that actually Amazon has a model called Kronos. It's a large language model based time series data processing and forecasting tool. It's just open source, and a lot of utilities start to kind of look into that as one of the source. Like you said, is ensemble at the end, right? Many different methods. We have to choose that. So that's one key area. The other area is really looking at the grid modeling and planning area, right? And how can we use AI? And we already start doing that to build a better model to generate the right scenarios for grid planning, and leveraging HP high performance computing to do more simulation and use that generated synthetic data to make decisions based on the large scale of the power system simulation data. The third area I would mention, maybe we can dive deeper, as my dream would be really bring AI into the grid control room. So really having AI to support operators. Not operators still very important, right? But having AI to really support them, especially during the extreme weather conditions.
Let's go a little deeper on forecasting. Sean, you mentioned, the intermittent resources that are becoming increasing parts of our grid. Obviously, better forecasting for those is super important for the way that the system is operated. But better forecasting on the demand side is important too. Obviously, weather data impacts demand. So, how are these various pieces kind of showing up? Why is this advanced forecasting, leveraging AI, such a critical component?
I mean, if you look back at how we originally forecasted, you took historical usage and just flipped it on its head and said that's whatever happened last year is going to happen next year. Everyone went to work at 8 o'clock and came back home at 5 p.m. I mean, as much as we talk about climate change, COVID changed how all of us work, right? So many of us sit at our homes and work now. Everything changes. Electric vehicle penetration has gone up. Off peak is no longer really off peak. It's the duck curve might actually be more off peak than off peak is. And so you're seeing all these different issues, and this is where we really need to have something that's smarter than a person sitting at a spreadsheet dealing with all these issues, because we keep having a really mild winter and then an extreme cold pop and then a really mild winter and then another extreme cold pop, which is what we sat through this year due to the polar vortex kind of construct.
Xing, you want anything else on forecasting, or can I ask you a different one?
I just on the forecast side, we also a lot of utility looking into probabilistic forecasting or planning, right? And which is really, I think, so we know grid modernization represents large capital investment into our grid, especially on the distribution grid side. But where to put the investment to facilitate the electrification of transportation or heat, right? A utility is struggling today on getting that more accurate, like Sean mentioned, getting that more accurate planning scenarios so that they can convince the regulators that is the right investment that they're putting on, right? So I think that's remain to be a challenge, and where I see the AI really is going to help a lot.
So I'm going to kick the large language question to you, Xing. I mean, everybody's battling for the latest version of the best large language model. Are you seeing these types of solutions get leveraged in back office or other capabilities at utilities, and how and where?
Yeah, very much so. I think this is remain a hot topic at Amazon and when we talk with our customers, right? I think the question really is not to debate which model is better. I think our philosophy is to make the model make more choices to our customers, right? And based on what their business cases are. And for example, generative AI has been used for its coding companion to power the development team to make them move faster, to reduce costs. For document processing, it's being heavily used, right? Especially in some of the industrial, like oil and gas companies or utilities, use that to process document and build knowledge base, and then use a generative AI to build agents, right? And to help their own employees or even customers to tap into those knowledge base. And I can give also some other more advanced examples, like bring the agents into the contact center and help customers to understand the outage scenario situations. And I think this is something that I feel personally, like we had a 5-day outage in Seattle area due to extreme weather conditions, not long ago. The people get anxious, right? After days, when power is back. So can we use generative AI to build agents to better communicate that with customers? That would be a great improvement on the customer satisfaction side.
Yeah, we've got a number of people in Seattle, and they definitely felt it. But luckily, all of us in Houston had that playbook from May and July last year. So I think it's also really helps on the efficiency side, right? Like, I don't have to sit in a ton of meetings now because it will just give you notes from the meeting and give you 10, 12 bullet points, and you're able to sit through that and get that time back, because time's the thing. It's our most valuable resource, right? Yeah. But it's also not 100% infallible. I had one the other day, and we were planning for Sarah Week, and it kept on saying that it was South by Southwest, and I was like, wait a minute, how'd you pick a different conference? So it's not, I don't feel it's taking my job anytime soon.
So we haven't really covered, I mean, this is an application, some of LLMs, but I think an area that seems ripe for AI deployment on the near term is kind of streamlining some of these extensively complex processes, regulatory proceedings, legal filings, interconnection queues. Sean, are you seeing anything show up there that is exciting to you? I know it's a little bit a field of what you guys do, but anything on that side that you think is interesting?
Yeah, I definitely think this is going to be what's helpful in cleaning up the queue. There's a few startups that we're friendly with who have gone in and helped on that side, and will go into like a MISO or an SPP or an ERCOT and really help with this, because as I mentioned earlier, the queue has a lot of noise in it. And so really pulling that noise out and saying whose data center is this, or whose transmission line is this, and why are these at the exact same location? We can't be building both. It's going to be very helpful. Regulatory filings and legal, absolutely. There's a lot of really cool startups that are branching into that space, because at the end of the day, it's a ton of reading. And if someone else can do that for you and summarize it, just as I was joking about our calls. If I don't have to sit through an hour call and somebody can give me 10 bullet points, that's great. And same thing with being stuck with a few 100-page document. So I definitely think that this is, again, time. That's the valuable resource that we're really trying to save here.
Interconnection. I know Grid Unity. Do you want to shout out anybody past that?
There's a handful that are doing it in this space. I mean, Grid Unity is good. There's like Pearl Street does some good stuff. There's a handful of others, but yeah, I think this
and on
is
the regulatory side, I was just hanging out with H-Data because I was at NARUC. Nice. Ching, anything else you want to add there? I can send another question your way too, though.
No, I was just you mentioned Grid Unity, Pearl Street Technologies. Those are our partners. We actually work together on one of the RTOs and try to accelerate the interconnections using both AI and engineering automations. And we were able to actually cut the model build process from 3 months down to 1 week. Just through the automation. I mean, this is really, I think this is real, right? So we're starting with that. And also, the next step indeed is to look, using generative AI to create the interconnection agreements and perform, some preliminary, legal review. Again, it's not replacing anyone, but it saved a lot of people's time.
Tired of costly grid upgrades and unpredictable demand? Virtual Peaker's AI-powered virtual power plant software empowers utilities to maximize the value of distributed energy resources. The cutting-edge platform optimizes DER operations, enhances grid stability, and unlocks new revenue streams. Learn more at virtual-peaker.com. Now back to our episode.
I want to pivot over to predictive analytics. This isn't brand new, and it merged into machine learning, and now it's coming in, maybe coming into the AI space. Ching, I'll start with you. Are you seeing hardware instrumented with enough intelligence that we're really going to know about problems before they occur? If you're seeing that, how is it kind of showing up in the way that operators are running systems?
Yeah, it's actually very real. When we talk about this, it's not just AI. We're touching also a number of areas that you have to gather the IoT data, right? The IoT sensor data coming from in real time, coming from those devices. You need to also connect the asset management systems with AI, IoT information, and then build a machine learning model, a deep learning model based on that to detect anomalies, and hopefully with the operator logs and repair logs, you can do predictive maintenance over there. And this is in high demand. So in terms of anomaly detection, we have been working with many large utilities like Portland General Electric, the Duke Energy's, Enels, and really to help them leveraging IoT information, even image data, trying to identify the issues right in real time, and also provide preventive kind of actions, recommendations to them.
Anything on that one, Sean, or you want me to send the next one to you?
No, predictive analytics is extremely important. I mean, if we're sitting there trying to figure out what the payback period is on like our battery, for instance, if you just aren't there, then you can't make that money. We need to make sure that we have a resilient grid for especially summer and winter, but we're also having crazier events on shoulder season, which used to not be overly exciting. The other thing too is if you know when something breaks, then you can deal with the supply chain, which I know no one ever has supply chain issues. And so this is something we were joking about on stage 2 days ago at Intersolar. Myself, STEM influence going into all the supply chain issues that are going on, and predictive maintenance lets you really get ahead of those things so that you can actually, again, be functional for the grid, because you need to show up, especially on the generation side.
Yeah. I want to dive in a little bit deeper on the grid visibility side, right? You've got basically near real-time sensors coming in, if not embedded on actual assets, coming in separate. You've got drones. You've got really cool image recognition capabilities. You've got GIS integration. It's an exciting time to leverage this capability. We still don't have eyes on the grid, I would say, in a lot of places. But Sean, are you seeing kind of this ubiquitous sensoring, advanced control space bringing us to an area that isn't just talk about IoT, but is really starting to show a lot of real world benefits?
Yeah, I think the drone space is especially interesting. And one of the things back when we started our company and was doing a lot of pitch competitions, it took me a second to wrap my head around all these different vegetation management companies. But then when a tree fell in my neighborhood and took us out for 7 days on a power standpoint, it made a ton of sense. And so I really think that the whole drone and kind of IoT is going to be extremely helpful because, again, we're kind of trying to put Band-Aids on something that's 100 years old. So we need as much help as we can get.
I know you guys are active in a ton of these spaces. Xing, anything there?
Yeah, I would say that also it's important to map all of this data together to break the data silo, because right now we've got all of this information on different platforms and at the utilities, and their main challenge is really lack of single source of truth, right? And be able to effectively use that data to generate value. And this is what we're focusing on at the moment with some of our utility partners.
So Xing, I'll let you finally talk about the control room, right? I wanted to get a long ways into there before we actually were going to talk about IoT showing up there. I know operators are going to have a lot of hesitation. It seems pretty clear. You tell an IoT system, dispatch the optimal hybrid power plant. It could do that. But where are we going to be more comfortable with these sort of automation capabilities coming in or close to the operation in the control room?
Yeah, so you got me started, and you have to stop me if you think I think. But I think actually, if you look at transmission grid today, it is actually semi-automated. There's that frequency regulation and things are automated, but a lot of things are manual and it's completely rely on the operator's experience, especially if in the distribution control room, right? So I think that's a lot of things are very, very manual. So I think our goal, I think, is to leverage AI, leverage existing tool set, right? Leveraging cloud-based high performance computing to do more studies in real time and look ahead time frame, and be able to generate that data, be able to train that model so that generative AI model can be used to not just perform intelligent alarm, but also be able to recommend actions and actionable actions to operators for them to consider, and be able to also validate those actions before we implement those, right? So there's a lot of things included in there. But I guess the good news is we are implementing those tools in the control room today, and they are still very, very valuable down the road in the future. The question is, how can we quickly build that trust with operators to start use AI-powered tools, leveraging that data, because operators cannot solve 1,000 power flow in real time in their mind. Machine can, right? Once we do that, how can we translate that data into useful actionable information for them to operate the grid?
I mean, I think the way we do that, and I do not have the solution for this, I just have the problem, is changing how we incentivize utilities, right? And so we've got to figure out a way to let them, to force it where they have to go in and change and be faster and move quicker. So I think that's really the big problem. There's still a whole lot of spreadsheets that have been built 20 and 30 years ago that are keeping our lights on, which is kind of scary if you think about it. So we've got to figure out a way to change the incentive structure for them to adopt these. But I'm completely on the same page as you in terms of what needs to be done in the control room.
So I'm going to pivot us a little bit. Sean, I think you brought this up, so I'll kick it first to you. But Xing, I know you have feedback on this. Data centers are massive loads. Historically, they showed up in a community and said, just give us power. But I think there's an increasing understanding that we need more flexibility from this load. We are pretty close to a federal project that hopefully can get unstuck. But we described 5 categorical areas of where we think data centers could be more flexible, right? They're not a CNI load that's just going to dim their lights or turn off a process, but they could change their operations. They could deploy deep efficiency. They can bring new forms of backup power on. They can work with their grid operators and supply them more dynamically with the generation they're buying. They can partner on these grid enhancing technology programs. It's a pretty cool list. Sean, where do you think data center flexibility may head here in the near term, and how do we get those loads to be more flexible in the communities they're showing up in?
Yeah, I love this question. Duke University just came out with a study based on having flexibility around load. They went all the way out there saying that we don't need any new transmission or generation to actually deal with all of the new compute that we're going to have. It's an excellent study. If you haven't read it, I got to meet out in San Diego, Tyler Norris, who kind of headed this up. And there's some really cool startups like Emerald doing this as well. And so this is going to be the answer. I mean, just as demand response and VPP for energy has really helped the grid, it's going to be the same thing in terms of moving your compute around. So I definitely think this is a lot of the solution.
Xing, you have any comment on data center flexibility?
Well, I think, actually I have a slightly different view, right? But the data center actually also is considered as critical infrastructure more and more today for many business and even our government agencies, right? So I mean, for critical workload, it's not really flexible, right? And for traditional data centers, it's not really that flexible. But I think things are changing, right? With the more AI targeted data center coming up, those AI training workloads definitely can be flexible. I think it's really putting the right pricing mechanism, incentive mechanism, so the customer will be able to shift their training loads, from different times to, just to help with the grid and increase that flexibility. And also, I think from the distributed generation and storage technology growth perspective, right? So with more and more those technology being installed at data center to provide resilience, and they actually can provide some needed flexibility when grid cost for them.
Yeah, they're definitely critical infrastructure. And I mean, from our standpoint at Amperon, our wind and solar forecasts run every 5 minutes. I need you to run every 5 minutes, please. Other forecasts run hourly, need that run every hour. But if it runs at a different, like couple minutes apart, it's not the end of the world. But then our long-term forecasts actually run like Monday night. So you can take your sweet time there if you want. And those are the ones that are actually compute heavy, just dealing with going years out. So I think that there is, but I agree. I do not want someone to say, hey, by the way, it's a really high price event. We're not going to be able to deliver your predictions, because then all of our clients are going to be really frustrated because the time they want us the most is during those high priced events.
I could tangent us for the whole time. I love this topic and can't wait to see what starts unfolding on that area. But Xing, I'm going to kick this one to you. Bad goes to worse if outage is both power and internet, right? These are backbone ecosystems of our lives, of business, of society. How important is, getting resilience right for these areas that have their overlapping, needs, not only the power supply to them, but if there's some AI solutions that you think can address it?
Huge. I think it's certainly, I would say that from a resilience perspective, not just power supply, like you mentioned, the communication, the internet, right? That is why I think we're kind of launching that Project Kuiper. Really is our own low Earth orbit satellite system that's going to connect to our data centers that will be able to provide reliable communication in those in remote areas or in those conditions. That's very important, right? I would also say that utility need to do more preventive actions that include that we just discussed. Bring AI in the control room to pre-position the grid to minimize, right, the outage to the impact to the grid, but also to restore faster, leveraging AI. And also prepare for the disaster recovery as well, right? I mean, running your critical systems at different locations and even in the cloud, right? To be more resilient to any of this. And the last thing is the DER, right? So I think the resilience will drive the DER growth for sure. I have a standby generator now. And I think, certainly I think more and more people will have EVs and solar panels, and we should consider how to leverage those to build that community of the local grid.
Anything on resilience, or can I kick the other one to you, Sean?
Yeah, my wife got a purse and a Westinghouse for Christmas. So I'm on the same page with you. We've got a big generator sitting in the garage now. But yeah, resilience. The thing is that we used to have like a 1 in 100 year event roughly every 100 years, and now it's every few months. I mean, I did not win. I'm a complete weather nerd and energy nerd. I've been doing the exact same thing for 20 years. I did not know what a derecho was until it came and blew through Houston and took everything out with 100-mile-per-hour winds. So, I mean, we're having to deal with resilience so much more. And again, the grid is not getting any newer. We built an amazing grid 100 years ago, and then everything showed up. More people came to this country. More people are building data centers using compute. So that is definitely resilience. I think everyone's top of mind now.
Yeah. So I got a pre-last question. I'm going to kick it to you, Sean. Xing, you can add on if you want, and I know we're going to end up here. Love utilities, but they're not traditionally considered, the examples of the most innovative organizations. On the flip side, tech companies innovate or die, or innovate or can't compete, slowly die. What are these two worlds that are colliding right now, learning from one another, Sean? About how we bring innovation together, adopt it, deploy it, iterate on it.
I mean, that was the thesis of Amperon. I was living in New York City, but I grew up in the suburbs of Houston, and I saw data engineers, data scientists everywhere in like 2017, 2018. And I thought, I love arbitrage, being a trader. And I thought if I could hire data engineers, data scientists that worked at like an Amazon, Google, Meta, et cetera, and bring them to all us country folk here in Texas who know energy really well, then we would be able to like build a really great company. And so that's been the thesis the entire time. So I think that move fast and break things works until it doesn't, but move slow and just keep status quo doesn't work either. So I think there's a lot both can learn, but I think that everything in moderation. I think they need to find the middle between the two because we can't just magically put over a brand new AI solution in a control room that is going to black everything out because it's not proven and tested. But on the other side, we also don't need the same person who's been in the exact same seat for 40 years controlling the grid.
Anything on this one, Xing?
Yeah, I think we need to start build trust with the utility business team, right? So I think the utility IT team actually want to move faster, but business has concerns. We really need to start build trust and helping them to address actual challenges with technology, right? So that they are part of the game. And with technology, I think, for example, we have the Amazon Q for developers. Those are really tools that can help the business users to becoming a pretty good programmer. And they can do certain things faster themselves. I think that's basically just bring the innovation to be part of the business operations on a day-to-day basis. That would help the utility to move faster, not completely rely on critical vendors to help them to move, or the IT team to help them to do everything.
All right, last question. We'll put our forecasting hats on, which would make any of us billionaires in this space. But thinking back to the last 2 months, let alone 2 years, it's been really breathtaking on how fast things are evolving. Let's look out maybe 3 or 5, not too far, not multiple decades of core grid infrastructure, but, an iteration of IT infrastructure. Let's look out 3 or 5 years. And what does success look like for applying these AI capabilities on the grid? How has this gone somewhat well, or we've done something effective, or we haven't broke something? I'll have you start, Sean, and then Xing, your last word.
I mean, 3 to 5 years is going to be interesting. I don't think it's going to be as hyped up as everyone thinks it is. I don't think we're going to have 150 gigs in ERCOT. There's a saying when you're trading, buy the quiet and sell the riot. And I definitely think right now this is all everyone's talking about. This is what's top of mind. I don't think as many data centers are going to get built as we think there are. I think there's going to be more efficiency around those. So I think we're going to be in a really good place in 3 to 5 years. Demand is going to go up. Compute is going to definitely go up by a sizable number, but I think it's going to be muted compared to what we currently think and what we're currently having out there for predictions.
How about you, Xing? What does success look like when we're out here a couple of years?
So yeah, from 3 and 5 years, I'm very hopeful that the AI adoption, will be much wider in the utility space. For example, I mentioned a few things. I really want to see that the AI would be completely adopted by the grid modeling and planning and forecasting. That type of long-term business divisions. They would rely on the AI tools to be able to make investment decisions. And I also go to the real-time operations. I think some form of AI advisor will show up in the control room, and the operator will start to accept the concept of artificial intelligence to help them making the right decision in the real time.
Well, Sean and Xing, this is the tip of the spear right now. Thank you so much for being on with us and chatting.
Thank you so much.
My pleasure.
Okay.
Thanks again to our season sponsor, Virtual Peaker. If you enjoy GridForward Forum, please follow us on your favorite podcast platform, give us a like or a review, and tell your colleagues. You can listen to all episodes and learn more about our efforts to advance the grid at gridforward.org.